Breaking news! Our top story today is Yielding for No One, a Tensile testimony. Good afternoon, everyone. I'm Sally Mayweather, and I'm here to guide you through today's story. What are tensile tests, and what do they want? Here's a live look at the procedure and what these subjects had to go through, this one being the aluminum. Now, how does one measure a tensile test? Tensile tests can measure a variety of different things: elasticity, yield stress, ultimate tensile strength, percent elongation, and reduction of area. Now, let's break down the numbers. Here are 3 images of the elongated subjects: steel, aluminum, and the titanium. As you can see, each one of them is being measured, and this is to measure the percent elongation and the reduction of area. And those numbers we'll see in the next slide.
Thank you, Sally. Chet Baker here to show off the graphs of the experiments conducted today. The most important one is the one on the right, the stress-strain graph. As you can see, the steel had the highest yield and ultimate tensile strength, actually being relatively close to each other. However, the elongation was just not up to par, falling a couple percent short of the standard mark. The titanium sample exceeded standards in all aspects, with its elongation being nearly 7% higher than expected, and both the yield and ultimate tensile strength overperforming. Last, and in some ways the least, the aluminum didn't quite get to the 310 UTS mark, but exceeded standard in the 2 other benchmarks. Here we can see the 3 samples from left to right being aluminum, titanium, and steel. You can very clearly see the necking and elongation caused by the tensile machine. We tried to get comment, however, all 3 refused to comment for the news today.
As stated earlier, one of the reasons behind doing this testing is to see the change in length of the bar as it is pulled on. Data that we found had a measured final length of 2.445 inches for an aluminum sample, 2.494 inches for a titanium sample, and 2.275 inches for a steel sample. That is roughly a 78% increase from what we would expect for the aluminum, a 24% increase for what we would expect for the titanium, and a 34% decrease from what we would expect for the steel. As you can see, tensile testing is very real and hurts many samples every single day. With that, our broadcast is coming to an end. We have been Group 2. We hope this has been informative, and we'll bring you updates as things arise.